So here's the current state of the project. Let's turn this off. On. So the chip communicates with the GPIO and the RTC, but I don't have a way to show the RTC yet. Basically the real-time clock. So as you can tell, we're reading voltage. Well, there is a bunch of voltage drop due to very small wires, and the basics for the gearing and other detection is set up where it pulls it down to the ground. So if I touch the ground wire, this piece is connected to the ground. Here we go. We have first gear, neutral, second, third, fourth, fifth, oil, and rear shock pressure. So that's what I have coded so far. Well, the only issue with this is that my voltage regulator gets scorching hot in here. So this heatsink is way too little, and when we close this up in the enclosure, this will just fry up. So, as any sensible person would do, I went out and bought a heatsink that is total overkill for this project. So the idea is to put it on the back and mount our voltage regulator to this. Right about now I realized I should have drilled these holes from the other side so they would go nicely in between the fins on the fin side, because otherwise I'm hitting the fin in the middle and the hole kind of goes sideways, and then the post I screw in goes sideways. So anyhow, I'll have to redo this when I do the mounting plate and put the holes from the fin side so they're nice and straight. Yep, it's warm. There we go. This thing needs to be isolated. This voltage regulator has the output 5 volts on the mounting tab. So when I'm mounting it, I have to put in an isolator in between the heatsink and the voltage regulator. So I'm applying some thermal transfer paste for better heat transfer on both sides of the isolator and the voltage regulator. Yuck. Cool. We're back. I'll just let this sit here for a moment and see if it heats up any. So let me show you real quick the code for current display. Right now it's really dumb. I have defined a bunch of variables here where my CPU sends the data into the variables, and there is one timer event that assigns the data from the variables to these on-screen controls. Right now it's real dumb. I'm gonna work on making a nice display the very last. First we need to figure out how to get all the values and code all the logic inside the Atmega CPU. Here we go, more progress. Managed to start the real-time clock chip. Well, the time is not set, but it's running and counting seconds. Success! Okay, so I made a mistake with how I implemented the detection of the 12-volt signal with the optocoupler. So let me show you what I've done. So basically, if we look at the optocoupler setup, so when the signal comes in on this wire, 12 volts, the LED inside basically fires and opens up this transistor that allows flow from pin 5 to pin 4 to ground, and basically pin 5 in this case is directly connected to basically to a GPU input. Basically I'm trying to catch the signal here, and that's not gonna work because the flow is going this way, so I'm not getting a ground. It's not getting pulled to ground. So we need to rewire this a little differently. So let's fix this. So we move the ground out. The same way here, so we need a resistor. Actually we need two resistors, one like this and one like this. So basically we do come on, we're running out of space. Okay, so this will not be needed here, and this will go like this. This will go like this. Where's my wiring tool? So this goes here and this goes here too. Come on. So basically we have a path to ground for our 5. We need and we need plus 5 volts. So basically the schematics have to look like this for us to sense 5 volts here. So we actually have to flip. We'll catch 5 volt input here, so I need to disable pull-up resistors in the code to actually not pull them up. So we don't need to invert the signal, so we really, when the signal is present, we'll get a plus 5 volts here, so we'll read 1. So here we go. Let me fix all the other schematics, make it all pretty, and I'll show you the finished work. So here's the fixed up schematics. So this optocoupler got 2 resistors, output pulls out to ground, 5-volt input. The same thing with these, exactly same basically approach. We supply 5 volts, when the signal comes in, this opens, we detect 5 volts. Now let's go and fix our mistakes in hardware. So here it is, we fixed up one so far. And if we apply 12-volt input here, get on, here we go, detecting, and this is 12 volts coming in. Need to speed up the communications with the display. So, success. Now we need to replicate that 3 more times. Here we go. We have an working RPM. So I have this shitty signal generator running at 10 Hertz right now. We can stop it. So RPM stop. Can bump it up to 20 Hertz. Basically that's 20 pulses per second, which equates to about 1200 RPM. We're pretty close, yeah, give or take. So we're at a kind of good measurement. So I hooked up my $20 to $30 do-it-yourself kit oscillographer to see if we actually pass the optocoupler, because this poor guy barely pushes 7-volt square wave. We were counting on like 12 volts, but it still works. So here we go, RPM gauge works. Well, detection of RPM works. So my 12-volt signal detection also works. There we go. So here's success. Need to do some work on getting the battery hooked up, enabled in the clock, because right now we're losing time every time I repower. What else I need to do? Oh, I need to code the voltage dividers for fuel and temp, and pretty much replicate whatever we did for RPM for speed. So getting close. Here we go, the basic programming is done for all this. So we have a speed, well, this is running from the same 40 Hertz, and I'll see how many magnets I'll glue on the disc or on the RAM somewhere, so that will be calibrated correctly. But this is now just to kind of get the signal on and see how things are progressing. I implemented the battery power, so if we kill the power and we come back, the time keeping continues. We implemented the voltage dividers for fuel and temp, so if we ground out this side or this side, we're reading voltage change, so we'll know how much fuel and what temperature we are at. What else? These things are working. So pretty much everything's implemented how it should. Now we'll have to hack this into the Goldwing. Maybe I'll come up with some way to mount these both together. Need to find some piece of aluminum plate or something and try to throw it on the bike and hack all these wires in. So stay tuned.